Morning. Today I will discuss about states of matter and chemical changes. Chemistry is the study of composition of matter and its transformation. Chemistry deals with the study and behavior of the chemistry concerned with the composition, structure, and properties of the matter. And the phenomena occurs when the different kinds of matter undergo changes. So based on the states of matter, uh, matter is divided into four classifications. One is solid, liquid, and gas, and plasma. Generally, we studied only three states, solid, liquid, and gas. The plasma is the newest one. So first we will discuss about the characteristic features of the solids. So solid is nothing but it is tightly, closely packed together. See here, the molecules are tightly and closely packed together. Here, these solids have a fixed shape and volume, and these are having rigid nature. And the particles cannot move. They have rigid structure. Here, there is a strong force of attraction between the solid particles. The best example is solid ice, sugar, rock, wood are the best examples of the solid. See, next one is the liquid. Liquid is nothing but the particles are less tightly packed when compared with the solid. See here, in the last term, the particles are tightly closed here. There is no space, there is a less space between them. So here the particles are little bit loose when compared with the solid. So here these liquids have the shape of the container. These liquids does not have a fixed shape. So if we pour the water in a glass, the shape of the glass. If we pour the water in a bottle, it is the shape of the bottle. So liquids are have fixed volume but no fixed shape. So these liquids rate of diffusion is high when compared with the solids. Here, the bond between the attractive force between the molecules is very less when compared with the solids. So liquid state, best examples are water, milk, lead, coffee, etc. And gaseous state. So here the particles are far apart from each other. See here the particle, this is a one particle, this is a one particle. There is a large space between the particles. So here the force of attraction is very negligible when compared with the solids and liquids. So these are having no fixed volume, no fixed shape. So when compared with the solids and liquids, the diffusion rate is very high when compared with the solids and liquids. The kinetic energy of the particles is very high when compared with the solids and liquids. The best example of gases are helium gas, air, nitrogen, oxygen, etc. And the last state is the plasma. Plasma is not generally seen from the matter. The plasma consisting of particles of extremely high kinetic energy. Electricity is used to ionize noble gases to make glowing signs, especially in the plasma. Superheat form of the plasma. What are them? Those are stars. So, see here in the diagram, the plasma contains ions and electrons. So, this is the plasma. This is a small animation regarding the plasma, free movement of ions. So see, solids are fixed shape, volume, density is high, slightly compressible. So in compared with the liquids, there is no definite shape, definite volume is there, density is mid to high and slightly compressible. These are no shape, no volume, density is very low and highly compressible. So when the gas molecules are heated together, we will get a plasma, positively charged ions and the electrons. This is called as a plasma. See, here the best example is here. Ionized gas is nothing but plasma. So this is the best example, ionized gas. So here, when we are heating, when we are applying heat, the solids are converted to liquids. When we are applying some amount of heat, here the liquids are converted to gaseous state. And you are supplying so much amount of heat. What is happening? The gaseous molecules are converted into ions, that is the plasma state. Ion is nothing but it is a positively charged species or negatively charged species. It is the combination of ions. Ions is nothing but positive charge or negative charge or electrons. So, in the reversible reaction is also takes place. Deionization is takes place, then it is converted to gas. Gas is condensed to liquid, and liquid is freezing. On freezing, it converts to solid. So, this is the states of matter. Next, this states of matter is again divided into two classifications. One is the pure substance, second one is the mixer. So the only one type of substance is present. Basing on the type of number of types of substances in the matter, we are divided into two classifications. Pure is nothing but it contains no other component. So mixer is nothing but it contains more than one type of substance. So in pure substance, only one type of atoms are present. Those are elements. More than one type of atoms are present. Those are called as a compounds. So here we go for mixer. If the composition is uniform, that is homogeneous, and the composition is non-uniform or irregular, that is heterogeneous. Then we go for a few examples here. So element is nothing but here we are taking example as a copper teapot. It contains only copper ions. So copper atoms. Okay. So here baking soda, it contains compounds. Tea, it is a homogeneous mixer. There is no difference. So, and a heterogeneous mixer is nothing but fig. Fig means it is a fruit. It contains flesh, seeds is different, and surrounding is different. So, those are heterogeneous mixers. Seeds are different and flesh is different, like watermelon. So, and one more example, the pure substance is nothing but it contains only one. Elements is nothing but atoms or molecules are present. Compounding is nothing but it contains different types of atoms. Heterogeneous mixer means not uniformly distributed. Homogeneous mixer means uniformly distributed. Okay, so mixer is nothing but it is a combination of two substances. The best example is bronze. Bronze is the combination of copper and tin. See here. So this is a pure copper. It contains single atom. So it is pure substance. To this copper, if you add tin, it converts as a bronze. It is a mixer. Okay. So next. Next topic in this unit is chemical changes or physical changes. Physical change is nothing but only physical state of the substance is varying. It is a reversible process and neither energy absorbed nor evolved. No new product is formed. The best example is a melting of ice. See here, the melting of ice. In ice contains water molecules, water molecules. When the ice is converted to water, this water is also contains only water molecules. That means only physical state only changes. Here we are observing only change in the physical state. There is no difference in the chemical composition. See here. Here also we are having water molecules. In the ice is also we are having water molecules. There is no change in the chemical composition and chemical structure. Only physical state is changed. So when the water is freezing is takes place. On heating, this ice is converted to water. On cooling or freezing, it converts to ice. This is the physical change. Few examples of physical changes: melting of ice, boiling of water, breaking of glass, chopping of wood, folding of paper, and baking of egg. All these are physical changes. So see, this is the melting of ice. This is an example of physical change. Okay, next. chemical change is nothing but here the chemical structure of the compound is changes. It is irreversible process. If we are taking, for example, CaCO3, this is a general common example. On chemical reaction, it converts to CaO and carbon dioxide. This is the gas is evolved here. Okay. So what is happening here in CaCO3, calcium oxide and carbon dioxide, both are liberated. So what is happening? There is no reversible reaction takes place. This calcium carbonate completely converted into CaO and CO2. There is no reversible reaction takes place. During the reaction, it may absorb energy or evolve energy. Here, the new products are formed. Okay. So, this is the best example. See here, rusting of iron. See the animation here. Before rusting, this needle is like this. After rusting, what is happening when the environment is in contact with the needle? What happens here? It is converted to rusting of iron. The brown color layer is formed on the iron. Okay, see the animation. So here there is no corrosion takes place. After some time, the color is turns to brown color. So this brown color is due to the formation of iron oxide. Here, when this iron is placed in the environment, it absorbs water and oxygen present in the environment, converts to iron oxide layer. So this is another type of chemical reaction. So see here, the color changes occurred. So during the chemical reaction, some color changes. Some of the reactions undergo color change. This is the color changes occurred. Next, another chemical change is ripening of fruit. Generally, raw fruit is like this. After ripening, it converts. After few days, it converts like this. So this is the small animation regarding the ripening of fruit. Next, this is the another chemical reaction. This is the precipitate reaction. What is happening when the sodium hydroxide is mixed with the cobalt to chloride? Insoluble product is formed here. This insoluble product is called as a precipitate. Okay. Another example is germination of seeds. The seed is converted to small plant. This phenomenon is also chemical change. So in few of the chemical reactions, some gases are evolved here. So during the chemical reaction, some gases are evolved. So this is the small animation regarding the evolution of gases in chemical reaction. So last example is the cooking of food. See, she is cooking some food. So it is not a reversible process. It is a reversible process. It cannot be back. After cooking, it cannot be converted into raw. Okay. Thank you.